To solve a polynomial inequality, we're going to use the test point method, or what's called the critical value method. We want to rewrite the inequality so that one side is 0. Then we're going to solve the inequality as if it were an equation. We want to find all of the places where that polynomial can be 0. We'll use the solutions to divide the number line into intervals. Then we'll substitute a test point from each interval to see whether or not the expression is true or false, and then we'll find the intervals that satisfy the inequality. Let's look at an example. Here I have x squared minus 2x is greater than 3. First thing I want to do is get a 0 on one side. The easiest way to do that is to move the 3 over. And so I have x squared minus 2x minus 3 is greater than 0. So now I want to know what makes the left side equal to 0. Well, if I factor into x minus 3, x plus 1 is greater than 0. I can see the things that will make the left side equal to 0 are the numbers -1 and 3. So here's 0, here's -1, here's 1, 2, and 3. So I know for sure that -1 is not going to be included in the solution set because at -1, this factor here will be equal to 0. So the whole thing will be equal to 0 on this side, but 0 is not greater than 0. So I know that -1, there be a hole, and at +3, there's a hole. Now what's curious about this situation is a polynomial grows smoothly. So the only way you can go from negative to positive is when you pass through 0. I want to know when this polynomial is positive, bigger than 0. So if I plug in a test point in this entire region, I'll know that either this whole side is negative or this whole side is positive. Because if it's negative over here, it can only become positive if it passes through 0. And there's only 2 zeros. So this splits the number line into 3 regions that we have to test to see whether or not these things are positive or negative. So let's pick some points here. So we're going to test our regions. So from this area over here, I'm going to pick the point at -2. So if I plug in -2 to the left, I'll get -2 minus 3 times -2 plus 1. This is -5 times -1, which is +5. +5 is positive, so that means here it's positive. That also means everywhere else over here it's going to be positive. Then I'll test a point in the middle region. I always like to pick 0 if it's possible, and 0 is in the middle region. So here I'm going to get 0 minus 3, and then 0 plus 1, which is -3 times +1, which is -3. So I know it's negative at 0, and so I'll know it's negative in every one of these points in between -1 and 3. Then I want to test something in the region greater than 3, that region over here. And so I'll pick 4 because it's over there. 4, it's definitely bigger than 3. That's going to be 4 minus 3, and then 4 plus 1. Well, that's going to be 1 times 5, which is +5, which means it's positive over here. Now, what do I want? What is the solution to this equation? It's anywhere that this left side is bigger than 0. That is, it's positive, which means I want everything over here and everything over here. Now, I can write this using interval notation. Starting from the left, again, there's a -infinity over here and a +infinity over here. It's going to go from -infinity up to 1, not including 1 or that -infinity. And then it's going to go from 3 to +infinity, not including either because there's holes. And now I do a union. This is the solution to that inequality.